Hey, hello, and welcome to the show. It's time again for JP's product pick of the week. It's me, JP, and here we are. Thank you for stopping by, everyone who's over in Discord, as well as people watching on Twitch and Twitter and Periscope and Facebook and LinkedIn and all the other places we're broadcasting. Hello. If you're wondering where the chat's happening, check out Discord. It's adafruit.it/Discord. You'll get an instant invite, and you can see all the good people over there saying, hey, Mr. Certainly, Hugo, C. Grover. Who else do we have in there? Gary Z, welcome. Welcome, everybody. All right. Let's do this. Let's get going. So the first thing I want to do is let you know that there is a place where you can watch the show and get a 50% off discount. And if you go right there to that URL, just point your device that has a lens, camera, webcam, whatever you like, at that QR code, and that'll take you to the product 904. If you watch from inside of the product page, you're going to get a discount. And I know that spoils the surprise a little bit, but this video is playing right in there, and you can get a discount on the product just now, just during the show only. It expires right after the show. If you have it in your cart, you have a little bit of a grace period there. But go check it out. It's 50% off. So with no further ado, let's have Lady Ada tell us about this product pick.
Okay, another revision. The STEMMA cutification train rolls on. Choo-choo. This stop is the INA219. You'll notice that I'm starting to get to like really old boards, like really, original boards that we've had for a very long time. These are the toughest ones to revise because, of course, we make a lot of them. We have to do a revision process. But we revised this board so it now has STEMMA QT connectors. It's still the lovable INA219 I2C power monitor, plus or minus 26 volts, I think like plus or minus 2 amps or something. You can set the jumpers on the back, but it's just like STEMMA QT. It's plug and play now, really easy to use with any of our STEMMA QT boards. I plugged one of these into a Clue and made a cool solar panel monitor over the summer, and that worked out real well for me. So I'm liking it, and we'll just keep QTifying the world.
All right, and in order to keep QTifying the world, I'm going to head over to my cabinet of mystery wonder drawers. Its name changes every week, I think. And I'm going to change outfits 3 or 4 times in the process and go get myself one of these little boards. Hang on. And there it is. Our product pick of the week is the INA219 high-side DC voltage and current sensor in STEMMA QT format. So let's first of all head over to take a look at the product page here. Here you can see if I reload this right now, it's gonna magically cut the price in half. So 50% off, it's $4.98, maximum of 10 per customer. Go pick some of these up if you want to do some current sensing and voltage sensing in your projects, and simplify the wiring a decent amount by using the STEMMA QT connector. You'll notice here that this video is active. You can watch from inside the product page, which we think is a nifty feature. And of course, if you look at the product page, this will give you a bunch of specs and info about the product, as well as a link, if we keep scrolling down, to the Learn Guide. So there's a few projects that have used this, and if you click on this first link, you'll head right here. This is the Learn Guide for the INA219. We also have this built into a Feather, by the way, this same chip. But the one that we're looking at here is useful for any microcontroller you're using. You can plug it into your I2C clock and data pins, as well as power and ground, and off you go. This also has, if you take a look at the last page in the guide, the downloads page, we can head to the Data sheet. So here it is from Texas Instruments. This is the zero drift bidirectional current power monitor with I2C interface. And I always like to look and see what are the suggested uses. Here you can see in applications it says things that you might want to use this chip in to sense your current and voltage: servers, telecom equipment, notebook computers, power management, battery chargers, welding equipment, power supplies, and test equipment. So what I'm going to do is take a look at it in a little sample project that I have here. So what I've put together, just to give you a little tour, I have an itsy bitsy M4 microcontroller here. And you'll notice this is the STEMMA QT connector that goes to header pins on the itsy bitsy, and that's what I've got plugged into the INA219. I also have another STEMMA QT cable connecting to this little OLED display so that we can see the voltage and the current. And then I've just set up a little button, and I have my external power supply and a DC motor. So I'm going to run this DC motor. The button allows me to turn it on and off. And then we can look at the voltage and current as we run the motor, as well as when we stall the motor, because the current draw when you stall is sometimes an important thing for things like robotics, so that you know what's the maximum it's going to draw even when the motors aren't turning, so that you can provide enough current protection as well as a beefy enough power supply. So the connections here, you'll see I've got, this is a 5 volt 2 amp DC wall wart, and that is going through this little adapter. I've put a little shunt diode here just to protect it from a voltage spike. This runs the positive voltage, so that's the deal with the high side current measure. It's not measuring this on ground, so the ground is stable. It's measuring on the current high side, or the voltage high side. So that power supply goes to the V-in plus, and you'll see that our board here has a little supplied 3.5 millimeter screw terminal. So I've got this running to the board so it can measure the current and voltage, and then that runs to the rest of my circuit, and that's where that is being drawn and used. And then you can see here I'm going to display the output here for voltage and current. So what I'll do is I'm going to hold up this motor here, and I'll press the button. And now you can see it's drawing about 170 or so milliamps. You could get fancy and graph this. You could create a nice min-max for yourself, so it'll let you know the maximum current you're drawing. And now you'll see what I'm going to do is I'm going to put a finger on this motor, and as it struggles, so imagine your robot has a little bit of weight to it, it's not freely spinning. Now you can see the current is quite a bit higher. It's almost double. We're running about 300 milliamps when it is struggling, and if I stop it entirely, you'll see we're drawing about half an amp, so just about 500 milliamps. And you can see there the voltage is actually at about 4.3 or so, and that will adjust a little bit as we stall it. And this is super useful because now, let me hit the button and stop this, we can test this without grabbing the multimeter and alligator clips and adding your multimeter into the circuit. Instead, you can kind of insert this very quickly into any circuit that you are testing to see what the current draw is as well as the voltage. It also has some other features for shunt voltage and some calibrations. So neat thing is we've got a very nice circuit Python library as well as Arduino library. If we take a look at the code here, and I can keep that in view just because I think it's a handsome looking little circuit. This is the code that I have running on here. It is using the H-bridge driver, so L9110 H-bridge driver, and my DC motor. I've got a little explainer up there at the top. I'm bringing in a bunch of libraries, including the INA219 library and some display stuff. I set this on the I2C bus, and I instantiate the sensor here somewhere after I'm done with all my display shenanigans. There we go. So this is Adafruit _ INA219 being set on the I2C bus. And then when I want to read it, and we can also just print this out to the serial display if we want, all I'm doing is calling these two things, INA219.busVoltage and INA219.busCurrent. .current. Those are then what I'm showing on the display, and you can see I'm using the button to start and stop the motor here. You can even see here from when I was first starting, I have the print statements for current and bus voltage. If I look at the serial display, the same sort of thing. So you can see it's not drawing much anything right now. If I turn it on, there we go. We're drawing our roughly 150 or so, and then I can get it to stall out at about 500. So easy to do. You don't need to use the OLED display. That's just a convenience. Makes it a little easier if you're putting this onto, say, a robot. And let's see. I think that's what we wanted to cover, yeah? So this, of course, like I said, you can use it in CircuitPython. You can use it in Arduino. And it allows you, since it's over I2C, to chain together a bunch of different devices for passing data around, such as in this case, I've got the INA219 as well as this little display. I think that's going to do it. So once again, I'll remind you, if you want to go and pick one up, head to this here product page. It's at adafruit.com/product/904. It's 50% off right now. One of our favorite little current sensing chips. We've used it. As you can see, it's a fairly early product number, 904. We're up in the 3,000-4,000s right now. So it's something that's been revised. Didn't used to have the Stemma QT connectors on it. Now it does. And like I said, we also have it on a feather breakout. So that is the INA219 high side DC current sensor breakout. And let me give you the proper outro here. Makes it much easier to do my recap video later. So that's my product pick of the week. It is the INA219 DC high side current and voltage sensor in Stemma QT format. And I'll go ahead and stick that on my Stemma QT board of goodness. And that's going to do it for another episode of JP's Product Pick of the Week. Thank you so much for stopping by, and I will see you next time. Bye-bye.